So happy New Year, guys! Welcome to the new year. I wish all the best for the whole year. May this year unpacks a lot of opportunities for you. All right. So let's start this new year with a positive note by completing today's POTD. Okay. So today's POTD says array pair sum divisibility problem. So what is the problem? Okay. So the problem is you have been given an array. You have an array mentioned here, and you have a k as it mentioned here. Now you have to tell, that is, you have to return a bool value that is true or false if the given array can be divided into n by 2 pairs, n being the size of the array, such that sum of each pair is divisible by k. Alright. So the problem is to divide the array into n by 2 pairs such that every pair is divisible by the given k value. If you look closely here, 56 if paired with 34 will be divisible by 10. Okay. 22 with 98 will be divisible by 10. You can check it on your own with the help of a calculator also. I'm sure that's why I'm marking it correctly. 12 with 78 will again be a pair, and similarly 11 with 69 will become another pair. So these are the pairings so that all the pairs are divisible by 10. So in this case we have to return true. Alright, I think the problem is clear to you. Now let's move on to how to solve it. To solve it, the brute force approach. What would be the brute force approach? So the brute force approach, I think, generate all pairs possible. Actually, all set of pairs. Okay, and see for all the sets if any set has all pairs divisible by 10. But this will be a tedious job. How to generate all pairs? That is, generating all pairs will take us all the pairs. You will require a exponential time. But the question says that we have to solve it in O of n time complexity using O of n extra space. So how would we do that? Okay, I guess brute force approach is clear to you. It's not worthy to code it down. Okay, so that I'm moving to the efficient approach straight away. So in the above section, you saw that 56 was paired up with 34, 22 was paired up with 78, 34, sorry, 34 not, 98 was paired up with 12, and 1 was paired up with 69. Our k value was 10. Okay. Now, if I ask you, what is common in all this? One is that sum is divisible by 10. Okay. If you see, can I represent 56 as 50 into, so 5 into 10 plus 6. That is 5k plus 6. Alright. And 34 as 3 into 10 plus 4, which will be 3k plus 4. Alright. Coming to 2, it will be 2k plus 2, correct? 78 7k plus 8. Okay. 98, 9k plus 8. 12k plus 2. 1 can be represented as 0k plus 1, and 16 can be represented as 6k plus 9. Now you see, when I add these, what will it become? 8k plus 10. Divided by k becomes k se k gaya, k cuts the k, and 10 by k will be equals to that is divisible, right? K is equals to 10 only, so k will cut it down, and the answer would be 9. Okay. So what did I observe in all these pairs? If I take this 6 and 4, now 10 minus 6 is equals to 4, 10 minus 4 equals to 6. Okay. For these two also it is holding 10 minus 2 equals to 8, 10 minus 8 equals to 2. Okay. Now 10 minus 8 equals to 2 here, and 10 minus 2 equals to 8. Okay. Now 10 minus 1 equals to 9 here, and 10 minus 9 equals to 1. Okay. Okay, correct. Now if you see, for a pair, this is the important note now. The algorithm depends on this not only. For a pair, we want two such numbers x and y such that k minus x percentile k equals to y percentile k. Alright, k minus x percentile k equals to y percentile k. This is what we observed above. Okay, so what can be the cases now? This is an important inference we have come down to. How can we observe if it is true? Okay. Now, suppose k is given to be 10. Okay. What can be the possible values of the remainder? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright. For k, let them be x. So we want k minus x. So with this, k minus x would be, you would say 10, but I would say 0 only. Because if a number has a remainder of 10 and the divisor is 10, that is not possible, right? The maximum value is 9 only. So in that case, it would be 0 only. So it is a special case. Okay. For 1, it would be 9, 2, 8, 3, 7, 4. Actually, it would be 6, then 5, then 4, then 3, then 2, then 1. Okay. If you observe for all these, this one, you would see if how would it be possible to form pairs. Suppose there are n numbers whose remainder by k gives 1, and there are m numbers whose remainder by k gives 9. Oh, gives 9. So what is the condition that I am successfully able to make the pairs? It should be that n equals to m, because each one requires a 9. So n1 requires 9. So m should be greater than equals to n. Similarly, n should be greater than equals to m if you look at the point of view from the 9. So these two conditions only meet at this condition, n equal to m. Okay. So what will we do? We will take a map and store the count of reminders in it. I will tell you the pseudocode afterwards. Okay, this one is clear to you. Okay. What would be your second step? We would traverse the map. Now check if map of x equals to map of k minus x, then continue. Otherwise, return false. Else, return false. After the loop, return true if somehow it reaches the end. But this condition doesn't tackle two of the subproblems, that is for reminder 0 and reminder k by 2 if k is an even number. Okay. For these cases, for 0, if I have a single 0, would it form a pair with anyone? No. If I have two zeros, it would form the pair. If I have three zero reminders, then these will be fair. These will form the pair, and this will be left alone. So I am able to observe we need exactly even zeros. Similarly for this, k by 2, 5, 5 pair. 5 not a pair. 5, 5, 5 one pair and left alone. So it should also be even. So these are the if cases we have to handle, and this is the else case. Okay. Also, I forgot to mention the base case. The first base case that should be the approach, that if size of the array, size of input array is odd. Is it possible now? No. If the array size is odd, however, we able to divide it into the pairs, right? Correct. So these were the base cases. Let's look at the pseudocode. The pseudocode works like this: create a map. Okay. Now for I belonging to the vector input, map of I percentile k plus plus. Now for I in map, if map of I equals to if map of I equals to 0, in that case if map of I percentile 2 equals to 1, that is odd, in that case return false. Else if I into 2 equals to k, and if map of I percentile 2 equals to 1, in that case also return false. Okay. Else if map of I is not equals to map of k minus I, in that case return false. After that the for loop will end and return true. What is the time complexity? O of n traversing the array two times, O of n plus O of n, and space complexity also O of n because we are keeping the counter only. Okay, let's code it down real fast. I hope the question algorithm was clear to you. If at any point you were able to not able to register what is happening, just leave the timestamp in the comment section. I will surely get back to you. Let me increase. Yeah. Now, what did I do? I created a map. Now, for auto it in nums, mp of nums I, sorry, percentile k plus plus, storing the count of the reminders. Okay. Then now for uh, traversing the map, for auto it in mp, if it dot first equals to 0. Now if it dot second percentile 2 equals to 1, in that case return false. And also add a condition here, or if it dot first start 2 equals to k, then also there is the same condition. Else if if it dot second is not equals to map of it dot k minus it dot first, in that case also return false. Otherwise after the for loop ends, return true. Let's compile and run it. There has been an error where, yeah, MP of num psi percentile k. Yeah, okay. I was using the iterator, so I will just do it here. I hope it should work now. Working fine for the test sample test case. Let's try it for submit also. Hope it works. So it is correct, running correctly. Thank you for watching the video. A very happy new year to you once again. And if you like the video, don't forget to subscribe it and like it. Thank you. Have a nice day.